high-paying technologies I'm learning in 2025. Disclaimer before we start, these are just my experiences and the circle that I talk to, the people that I'm interacting with, that lead to me thinking that these are high-paying technologies in 2025. It may or may not be that. If you are someone who's currently stuck in a job doing, let's say standard development, you're doing ASP.NET, PHP, MERN, Python, whatever. If you feel like you've hit a ceiling, if you feel like you're not learning anything new every day, these are the technologies that I am spending my time on. You can choose to at least explore them from the sides, dive deeper into it based on, how much time do you have. But if I had the full year free, let's say, for example, I would spend my time learning these technologies for 1 to 2 months, and the ones that I really liked, the ones in which I could clearly see a market growing or a company that I could get a job in, I would spend most of my time learning that technology. The reason to learn these technologies is fairly simple. You can either get a extremely high paying, 100K remote offer if you know a technology. If you either know the breadth of technology, that means once you join, you're handling everything. That includes front end, back end, DevOps, monitoring, things go down, production issues, CI/CD. That is one way you can get there. In the second path, it's easier to convince a company. It's easier for you to show proof of work. It's easier for you to negotiate, which is why if you've been given a choice of learning, let's say something like Django versus learning something like core, deep tech, video processing, it's a good idea to go for the second one if you can clearly see a company or a market that's growing very quickly. So we'll talk about some of these markets that you can think of that are slightly more than just basic web development or app development that you may choose to spend your time on. Where do I figure out these technologies or companies? It's mostly my circle, talking to friends who are in SF, following funding announcements, following what kind of companies are currently getting funded in YC, and then figuring out what's their tech stack and what an engineer there might be working on a day-to-day basis. With that, a very small disclaimer, this might not be an extremely beginner-friendly video. If you haven't coded at all until this point, might be a good idea to pay your debts, do the standard DSA dev grind for a few months before you come back to this video and, try to target one of these technologies. Let's get right into it. Number one is going to be agents. It's the hot word in town right now. If you talk to anyone in SF, half of them are building agent startups. What is an agent? Basically, an LLM is the simplest, 10x outcome that's come out of ML right now, which is give it some text, it responds back with some text. That is great, but that's not where we want to reach. Where do we want to reach? That's AGI, artificial general intelligence, where you don't have to do anything. We as humans can simply sit on the side and it'll keep on working and, make decisions that us humans have to take right now. Agents are somewhere in the middle. They do require some level of human intervention, but at the same time, they're trying to achieve a few things that you would expect from an AGI. They're LLMs sort of talking to themselves. Think of them as a bunch of LLM calls that happen one after the other, and there are some level of decision making that, is happening through the LLM. Think of an agent as a bunch of LLM calls that happen one after the other that help it make some decisions. And this agent is sort of connected to real world applications, things like your Gmail, WhatsApp, so that it can send you messages, notifications. It can call a phone number, it can sign into a website, so on and so forth. So I'll give a few examples of what these companies look like and what's expected once you join. For example, if you ever want to build a system that, let's say, talks to your customers and tries to upsell them on something, and at some point needs human intervention to create a coupon code, and tries to negotiate with a user, an end user of yours, to sell something specific, that's a good example of a workflow that you can create using a platform like this. When you create an agent, there are 10 different things that could go right, could go wrong, and hence if you look at the YC list of companies in this batch and the last one, there are a lot of companies surrounding agents. How do you make agents safe? How do you give agents access to money? How do you give agents access to your authentication, your Gmail? How do you make agents secure? How do you make agents talk to humans in the middle? These are sort of very auxiliary companies that are getting built out, which are sort of clear signs that this might be big in the future, or this is something that VCs are betting on to be big in the future. Why is that the case? I think, as I said, until we reach AGI, we'll sort of have to compromise with agents. There are middle ground between pure LLM calls and something like AGI, which God knows how far it is. Again, what is an agent? A good example of this is a voice agent. If you ever receive a call from Domino's to do a reservation or a booking, that's a good example of an agent that you're talking to. It's not a human on the other side. It's an agent or a voice agent that can talk to you, understand what you're saying, and talk to a database, figure out what times are currently available for that restaurant, and book the restaurant for you. These are real world use cases of systems like these. Fairly hot market right now. I think chatbots and voice agents are the initial set of things that you can think of doing, but now agents are going into a very weird direction of building very weird use cases. We'll talk about some of them in the next point. But agent as a jargon, frameworks that are used to create agents, agent marketplaces, and products built around agents is something I would spend my time on. It's nothing too complicated. It's a layer on top of LLMs, which is why as a full stack engineer, it's not too hard for you to dive into one of these. With that, we'll move to the next one, which is a very specific use case of, call them agents or general ML/LLMs, which is browser automation. Since LLMs have been a thing, I found a few very specific companies that solve problems that require a lot of browser automation. I'll take a few examples. Induced AI is a company that initially got funded for creating an AI that can control a browser. A similar example is, I just found one, which was Browser Use. It's open source. I think it's part of this or the last YC batch. That's one set of companies where you need to remotely control a browser. You need to give an AI access to a browser and let it navigate to various websites, talk to an LLM and understand what the user wants from the AI. A good example is I can talk to the AI and tell it to book a flight for me from Delhi to Bombay. It's very futuristic. And that's why a lot of these companies that raised to build this are now pivoting to something else. But another good example of browser automation is something I talked about in my recent live, which is a meeting bot that can join a Google Meet or a Zoom meeting and record the whole thing, transcribe the whole thing, figure out the action items, and create a nice doc out of these and email it to all the participants. This and many other use cases would involve you controlling a browser remotely. So this very niche skill of getting really good at controlling browsers via Selenium or Playwright or any other tool that you might have used to start browsers is a very niche skill that if you can master, then you can solve a pain point for one of these companies. Even though this is not too hard to do, I think as you scale this, if you have not a million, but let's say a few thousand browser instances running on the cloud, that's a hard problem to scale. So how would you do that? How would you start browsers? What if a browser crashes? How do you restart it? How do you make sure there is some level of reliability? Is one thing that would be important to these companies. So I already know this, so I'm not really spending my time on this. But if I was you, and if I hadn't spent time here, remote browser controlling tools, and in the worst case, this will help you write good integration tests. In the best case, you might be able to use this knowledge in a specific AI company. With that, we'll move to the third point. And I do apologize. I think a lot of these are very AI related, but unfortunately, most of the funding is currently in this market. So it's just easier to find companies who've raised recently and are currently, hiring aggressively for a problem. So the problem most probably is going to be, in some form or fashion related to AI. The next one is just understanding the code base of VScode, honestly. VScode is a fairly large code base. I think it has some more than 100K commits. And a lot of folks are coming out, the most successful one being Cursor. I think Cursor has proven a very decent business model. From what I remember, they're at 50 mil ARR, have raised at a $2.5 billion valuation. And not a lot of people around the world understand the code base of VS Code completely. And to build a company like Cursor, eventually they'll probably spin this out and, build the editor from scratch or hire a bunch of VS Code people, work with Microsoft. That's my guess right now. So knowing how VS Code is written, understanding how you can create extensions, let's say tabs, building a visual UI inside Visual Studio Code would be a decent skill to know. Reason being, there's just a lot of folks coming out. Windsurf is another one that came out by the folks at Codium. They're also valued at $1 billion. So believe it or not, either get really good at VS Code and understanding its code base, or a few other markets are all of these coding extensions sort of require them to work with not just VS Code, but let's say 𝗟𝗏𝗃 or NeoVim. If you are really good at a specific text editor or making extensions in text editors, you can be the go-to guy or even the go-to company for porting these AI extensions from VS Code to NeoVim, let's say. So that might be another vector I would take in these companies. And the next part here is indexing code bases as well. I think the reason that Cursor works so well is not just that they have a fancier UI compared to VS Code, but because they understand your code base really well. That involves a bunch of AI plus non-AI challenges. How are you indexing the user's code base? How are you making sure with a limited context window you can send the right information to LLMs? How can you make sure you're sending it faster? How you're making sure the response that's coming back is parsed correctly, so on and so forth. This knowledge can be used in a product not just like Codium or Cursor. You can also use this knowledge to build something like Devin or 𝗏𝗏𝗃𝗏, if you have heard of it, which was one of the initial GitHub PR bots that would automatically try to solve your issues. It's similar to Devin, but it doesn't have a fancy UI. It was just a direct PR integration bot that you would integrate with your code base, and it would start to either solve PRs or comment on PRs at the very least, point the developers in the right directions, so on and so forth. So this specific market, basically, developer productivity market, making developers faster, replacing developers, is now a very growing market. There are more tools to help developers code than, developers that are coding. That's, of course, not true. But at this point, it feels one of the very big competing metrics amongst OpenAI and, Google is who's built a better coder. So you'll see this sort of happening for a while. So for that reason, there'll be a lot of funding in this market. So one of these companies, even though, I'm sure they're all plateaued to some point, they're all saturate, and eventually there'll be one or two winners. But until then, there'll be a lot of funding. So getting into one of these companies, one, you can learn a lot. Two, you'll be in the center of the action, building for developers, building to replace developers. And three, of course, even if this doesn't work out, you'll have enough knowledge about talking to LLMs, parsing their response, which can be used in other use cases as well. So that'd be the third one. Understanding the core knowledge that is needed to build either a VS Code extension or a VS Code fork or a Devin-like application that, automatically creates PRs in your code base and tries to solve it, understands comments on it, so on and so forth. With that, we'll move to the next one. Next one is finally non-AI related. This one I've just kept as a side section, which is cybersecurity and DevOps. One sort of need that the company will always have would be to make sure someone is maintaining the infrastructure. And of course, cybersecurity is something that wouldn't be a thing if humans weren't dumb. Humans leave out things. Humans leave out security vulnerabilities, which bug bounty hunters find and then get paid. And something similar will happen with AI. Even if AI is writing code, there is a high probability it leaves out some level of vulnerabilities. So these are two job roles that you will always need a person for, irrespective of what kind of AI comes. Even I think if AGI comes, you will need someone to hold accountable / scream and yell at / wake up in the middle of the night if your things go down. So learning DevOps, and it's really hard to find DevOps engineers who are really good. And by DevOps engineer, I don't mean you're able to deploy your application on a VM. I mean, you understand how you can scale applications, infrastructure as code, moving to various clouds, making sure you're maintaining cloud costs, negotiating with cloud providers, developer productivity, CI/CD tools, testing, integration, so on and so forth. So all of these you will need someone to own. Not a lot of people know this really well. It's like compared to the number of web developers, the number of people who know DevOps really well is really less. So, that is one market. If you want to stay away from the crowd, or if you're extremely saturated in your job right now, then, you should look at. But this involves number one, some initial investment. So keep that in mind. Very standard. You need cloud access, to play with a few machines. Spend some money there. Don't think twice before running some experiments on various cloud providers. And number two, I think these fields may you really learn something well if you're working in a company that hits scale. Otherwise, you just deploy it to a VM. I've talked to a lot of startups in India. The engineers say, okay, we just have a VM. We deployed the database there. The database crashed and then, we lost data for a few hours. So you wouldn't really learn or get good at DevOps if you're working in such a company. The way to get good at DevOps is to work at a company that's really hit scale now and has, cost optimizations to do. Even if you save them 10% of the bill, that's a really big number. For example, one of our students got into a quick commerce company and he shared that their monthly AWS bill was somewhere around $1 million per month. So if you can save 10%, you're saving, 80 lakh rupees to the company, which frankly isn't too hard to do in cloud. Even through negotiations, you can save this much money. And if not negotiating, you can find ways to squeeze out profits. Of course, a company that's in quick commerce right now doesn't need to squeeze any profits. But in the long run, as a DevOps engineer, these are places you can provide value. You'll only be able to provide that value if you've joined a company that's hit scale. So unfortunately, there's no very easy path to learn, DevOps unless you join a company. That's not true for, let's say, mobile development or web development or even backends. So I would suggest कि किसी तरीके से, you start to own infrastructure of a company and, that's how you start to learn DevOps. For cybersecurity, there are two paths. You either go through a certification. There are various, commonly available certifications that people do, but a lot of cybersec people that I know are just naturally gifted. They've been hacking websites since they were young. They've always been interested in reverse engineering binaries or, going through standard web attacks and attacking a bunch of websites and slowly, moving from a black hat. So again, this one isn't a very clear path either. But I can tell you this one's lucrative. Number one, it pays really well to be one of the, higher paid bug bounty hunters. If you get into the right circles, if you're doing well on Bugcrowd or HackerOne, you'll get invited to private inspections of these companies. And when you do that, you can make, the best ones make like 2-3 million a year. That said, I also got my recent job through finding a fairly severe vulnerability in, one of these AI platforms. So that also sort of told me that companies, whenever they come, that also was a telling sign for me. Even without giving an interview, just because, I was able to figure my way around some very standard, commonly available vulnerabilities, I was able to get a job that's really hard to sort of replace. You'll always need people to keep inspecting websites and making sure they're safe. So these are two, again, decent attack vectors, even though cybersecurity is a little dilly-dally, by which I mean, it's just a little unstable because the company doesn't really need you on a retainer. They probably will hire you, make you do an audit, and then, won't need you later. So make sure you're comfortable with that lifestyle. But for DevOps, again, pretty blue ocean over there. I think companies would always need someone on call. And especially if you join a big company, there's like so much you can do. So it's always an interesting team to join. With that, we'll move to the next one. This one's again non-AI, browser-based XYZ. So there's Canva, there's InVideo, or a bunch of other companies. Let's see if I have another one. There's Google Spreadsheets. A lot of these applications were desktop applications before. Premiere Pro is still a fairly used desktop application. Spreadsheets was something people used to have locally, but eventually all of this moved to the cloud and to websites. There are many benefits of having these tools as websites. Biggest one being collaboration. The bundle size is really small. You don't have to download a full binary. You can just open a website and hit the ground running. But the problem is building these applications is really hard. Your browser isn't super powerful. There's a single JavaScript thread running that's processing everything. So if you want to do video processing, if you want to do video editing inside the browser, if you want to store a very big spreadsheet that has 1 million rows, you have to optimize it somehow. And the way you optimize it is by using web workers and, not just restricting yourself to the single thread that the browser provides you. So this specific niche of frontends that will be very hard for an AI to replicate is another vector for you to learn. It's basically going one step ahead of standard websites that you can build. These are the challenging bits in a frontend. I think, there are other challenging bits. It's hard to design frontends. I think that will always be a useful skill. But more than that, I think doing computationally hard things in the browser is something not a lot of people know very well. Another good example here is if you ever want to do video background removal like Google Meet does. That's also really hard to do in the browser because again, a single thread is doing 30 FPS video processing, then it will not be able to do other things. So all of that happens usually in a web worker. So what are web workers? How do they run? How do they make sure, okay, your browser thread is free to do other things while the heavy lifting is offloaded over there? That's a nice problem to solve. If you're trying to build an end-to-end video editor that's web-based, then understanding what exactly gets stored in the browser, how exactly the video finally gets rendered, probably on a server, are interesting, things to know because, yeah, as I said, these are not simple websites. So there's something extra on top of, the standard designing a website and building a website and state management that you have to do. With that, we'll move to there are two more points after this, which are super intriguing, but also super hard unless you're going for a master's or a PhD. These are image generation and core machine learning, as you could have guessed. I think a few years ago, it was really hard to code as well, like standard websites. But over time, you get people talk about it, people get smart, and then eventually, everyone knows how to build a website today. I think that'll be true for ML, AI, image generation, LLMs, whatever you want to learn. And you're very early right now. And we're also very early right now. Only, probably a handful of people know LLMs really well. So if I really had the time, honestly, if I had the time, energy, and money to move to the US for a few months, I'd probably go for a master's in these. But since I don't have that, I just have to figure out ad hoc ways, which is either going to be talking to my batchmates who are currently doing PhDs, or other ways to, learn these technologies. I've written a few of these down. The first one being image generation. I think video generation, image generation is doing fairly well now, and there will be use cases that come out other than, virtual only fan models. We've been using it fairly well in, a bunch of our videos, thumbnails. These are like very small use cases, honestly. There's a lot that can be done. Stock footages can be replaced. There are many use cases that maybe aren't fairly obvious right now. But at the bottom of it is going to be image generation. So how does, image generation actually happen? How does face swapping happen? What are diffusion models? What was the first diffusion model? What is stable diffusion? How is it different from, let's say, ideogram or the other one that I forgot the name? All of these have papers, thankfully, that you can read through. Not that it's going to be easy. That's why I said it's easier to go for a master's where you can find a community that's, doing this really well. There's not a lot of publicly available knowledge as to, or, broken down tutorials as to how this works under the hood. And I'm not talking about like building something on top of these that you can always do. I'm actually talking about understanding how diffusion models work, or, how images do get generated if you give a specific prompt. That's one. And the other one is, of course, it's core machine learning neural networks, but eventually building up to something like transformers and LLMs. That's the second very obvious, thing to learn, which will stay for a while, will be a valuable skill, will get you a job, so on and so forth. Because you already know, there's a lot of funding there, highest ROI companies, highest VC multiples are coming to, companies like OpenAI, which probably makes sense because they've built something new. It's very hard to build. There's a very strong moat. Only 3-4 companies will eventually be able to do it really well. And hence it makes sense to learn these. This probably for me would involve, going through the standard 𝗟𝗶𝗻𝗀 grind for a few months. Then there's this video that's really good that explains the transformer architecture. And then of course there's the 𝗟𝗶𝗸𝗀 video that will get you started on how to build a very basic LLM. At that point, I would, start to look out for either talking to a professor or junior roles, which are honestly hard to find in ML. That'll probably be the way to get into, ML without going for a master's or a PhD. But this is uncharted territory. I don't think a lot of people have, taken that path directly right now. But this honestly feels like the most rewarding path in the long run, because this is what is really disrupting, whatever that's standard full stack. That would probably be the most lucrative path in the long run. I'm still deciding. There are a lot of points that I've talked about here. Each has its own, put out a few points. Each has its own merits and, demerits. But let's get a study group, maybe. I don't know. Let me think about this. Where, we pick a few of these every month and try to study them. Honestly, if I look at the list, the most interesting ones to me are image and video generation. That's probably number one. Then it's going to be agents, purely because the one is the hot thing in the town, and two, if they're like real use cases that can be built, so there'll be a lot of companies that make a lot of money here. Then it would be developer tools, VS Code, autocomplete, GitHub PR, so on and so forth. Then it would be browser automation because it's just very easy. Then it will be core ML probably, browser-based XYZ web workers, and then well, tough choice between this and DevOps and cybersecurity. Yeah, this would be my list. In terms of top priority to the lowest, and maybe in the comments I'll do 7 comments on each one of these titles. Just upvote on which one you're learning, or what's your top pick to learn next year, and then based on that we can create the study group and go from there. The study group would mostly be silent learning every week. I don't know, it's very hard. People are like lose motivation fairly quickly, so it'll probably start off very strong and then eventually die out. So for that reason, we'll see how we structure it. But let's see where your core interest lies, and we can go from there. All right. Cool. That's all I had for this one. I will see you guys in the next one. Bye bye.